So that's our VAV connection. Fine. Now the last one. Last branch. Now this one, 138 liter per second, we have to resize. Whether it is mandatory or not, we can try now. Okay. So just I will be providing my acoustic insulation until this point. Okay. Up to this point, I will extend my acoustic lining. That's why I made that line. So now I am hatching it. Until this point, I will hatch it. Now after this point, I don't want this much internal, so I can decrease it. But before that, here 69 liter per second. What connection we can try? We can go for flexible duct and plenum box, or even if rigid connection is mandatory, but since it is 69 liter per second, the duct dimensions for rigid connection will be too less. Okay, I'll be going for flexible. So VAV for this room, anyhow, for discussion room 1, VAV I have placed discussion room 1 itself. Now I'll be proposing the thermostat for discussion room somewhere here. Discussion room 2, the VAV thermostat I'll be proposing somewhere here. Before going to this one, somewhere here I have to propose the VAV for discussion room 3, but here I am not having space. I'm not having enough space there, so that's why discussion room 3 VAV I'll be proposing somewhere here above the discussion room 2, but thermostat I'll be placing within the discussion room 3. Like that you can place it. Like that you can do it, no problem. Okay. So that's why it is clear that for 69 liter per second, what should be the flexible duct diameter? Flexible duct diameter for 69, we need 172. 172 means we need 200 mm. 172, we need 200 or at least 150 we need. But when we are making this as 150, what will happen to the velocity? If the fluid velocity is higher than 4 meter per second, it will be a problem. So this one, if I am selecting 150, 3.6 meter per second fluid velocity, even that is 150 is also fine. Only problem is the head loss will increase to nearly 1.5, but this is for GI only, and flexible duct is aluminium. So when we are doing the ESP calculation with respect to the absolute roughness value of aluminium, the ESP has to be overcome. I'll explain that. No issue. That's why you don't, even if you are getting 172, no need to go for 200 there. Even 150 is also fine. Try to maintain the velocity in the limited range, 3.6 less than 4 meter per second and all, less than 800 feet per minute. 800 feet per minute is how much? Means less, always final terminal, no, flexible duct velocity, try to maintain less than 800 feet per minute. 800 divided by 196.8, that is somewhat 4 meter per second. So that's what. Try to maintain that is somewhat near 4 point, even if that is 4.5, not a big issue. 4. Try to maintain 4. Okay, 3.6 only we are getting, even if that is 150, but head loss is slightly more. No problem, we can overcome it. Accordingly, we can select the ESP. 3.6. Okay, fine. I'll be going for 150 dia flexible duct there. Why not 200? 200 also I can use, but the problem, this much length from this duct, okay, this much length the flexible duct, I can't take it, because the flexible duct length is limited to 1.5 meter only. But in some 2017, they are saying you can go up to 2 meters. Still, SMACNA, that is 1.5 meter only. But 2017, ASHRAE handbook onwards, they are saying like a flexible duct length, you can go up to not 1.5 meter, 2 meter. I guess it is not there. 2 meter, like that they were saying. But still in SMACNA, that is 1.5 meter only. Where you can see flexible duct maximum length is 2 meter, correct? 2 meter. But all the other handbooks before it was 1.5 only. Only in this they are saying. Okay, 1.5. Try to SMACNA is 1.5 only, 5 feet. That's why this length is higher than that only. When you are considering, you can see the length is coming like a 2 meter or beyond that. So we can't use flexible until there. And also if you are using 200 dia flexible duct, because if you want to take a 200 dia flexible duct from this side, this height should be 250 mm minimum. Then only I can take it. Already this is 250 only, we are getting it. There is one problem. But if you are not using this flexible duct, because from the starting, this to this length, this point to this point, it is not possible to take the flexible duct. So that's why here we have to provide a rigid connection, means this one, which one? Shoe collar. Then the duct has to be extended until here, then only you can connect it. For example, if you want to take your flexible duct from the face of this one, this duct should have a minimum dimension of 250, then only you can connect it. So if this duct is having a height of 250, this duct should have a minimum height of 300 mm, but this is having just 250 only now. Understood? If it is not possible to take the flexible duct of 200 mm because I am getting 172 mm equivalent diameter from the duct sizer. I can round that into 150 or I can round that into 200. But if I am using 200 mm, from this point to here, if I am taking 200 mm, that is okay, but the length is more there, it is not possible. Why it is okay means since the flexible duct diameter is 200, the height of this duct, if you are planning to cut it from the duct height, the height of this duct should be minimum 50 mm higher than the flexible duct. So this I need 200 mm, that the flexible duct is 200, this height I need 250. That is okay, already we are having it. We don't want to decrease it, we can extend that. But the length of flexible, if we are using from here to here, that is higher, no? Horizontal plus vertical will come beyond 2 meters. So that's why we have to take a rigid connection. That rigid connection has to be extended until this point or somewhere less than 1.5 meter range. But if the flexible duct diameter is 200, this duct should have a dimension of 250. Then only from the face we can connect. Otherwise, I have to take it from here. Okay. Then from the side, I can connect it flexible. But even though if the flexible duct diameter is 200 mm, the height I need 250. The duct height is 250. This duct I need 300 mm height, but it is already 250 only. That's why I have neglected 200 instead of 172. I am using 150 mm. 150 mm. If the velocity is less than 4 meters per second, fine, use it, no problem. Okay. So now the restriction. Since the flexible duct that I am going to use in this branch is 150, this duct should have a dimension of minimum. Round duct you can take. Suppose instead of rectangular duct, from the duct side, if you are taking a round duct you can take 150 mm. Then this duct height you can maintain 200. Instead of, this is rectangle duct only. From the duct side itself, if you are making a round duct, round collar with a round duct, then that is fine. Even if 200 mm also, that is fine. 250 height only, that is fine. Then from this end you can connect. But if you are using a rectangular duct, the flexible duct diameter is 150. This duct I need minimum 200 by 200. This height is 200. Height of this branch should be minimum 250. It is already 250. That is okay. But what dimension we need there? 69 liter per second. We need 200, 100 only. We need 200, 100. Correct. So that's why 100, if you want to cut it from the face, intentionally you have to maintain that as 200, 200. Width 200, height 200. Otherwise, a round you have to use. From the rectangular height, you have to use the round. We can use this 100 because there is no other option, right? From the face, if you want to cut 200, otherwise you can do one thing, 100, 200 height, like that you can take. From the side, you can cut it. From the side, you can cut it. There is no other option. So this 100, definitely, like I should use this minimum 200, 200, then only from the face I can cut it. Otherwise, I have to enlarge it. 200, 100 to 150, like that I need a different kind of taper session. That is not practically possible. So this one minimum we should keep 200, 200. There is no other option. Or from the rectangular to round collar we have to use, then we can. I'll be going for 200, 200 only. Okay. And do that. I'll be using this one. 69 liter per second. There is no other option. So I'll be using that as 200 by 200 because there is no other option. Since the flexible duct diameter is 150, I need 200, 200 there from the face. Otherwise, I can do one thing. I can move this duct like this. Then from the duct side, we can take. Then it is fine. So your duct width will be 100, height will be 200. Then from the duct height, we can take it. That is okay. You don't want to make it. From the face, if you want to cut, you need which one? From the face, if you want to make, you need a 200 duct. Intentionally, you have to make it 200. Correct. Understood. So this one, from here, the duct will be coming. Okay. 100 only. The width will come 100. Height will be 200. So from the height, you can connect 150 collar. Then the flexible duct, you can connect like this. So duct will come like this. But if you want to cut it from the face of duct, suppose 150, if you want to cut, width should be 200, height should be also 200. Like that only we can connect. Intentionally, you should make us 200. There is no other option. So keep it there. No, it's not a big issue. We can do that. Okay. So move it with respect to this point. We place it there. 200. So since this duct is having a height of 200, this duct should have a height of 250. What about flow rate 138 liter per second? So 138 liter per second. The height is 250. 169.8 Pascal per meter. What happened? See, 200, 150 we are getting now. Yeah. I guess before it was wrong. 69 liter per second. This one, if the face you need 200, other dimension will be getting not 200, 100, 200, 150 you will get. 200, 150 that you can round into 200. Before it was coming like, because I have selected equality diameter, that's why it was coming so. Correct. Because if you, when I'm sizing before, I got 200, 100 only. So if you want to cut it from the side, from here, duct dimension, I was getting 100, 200. Actually, it was not 100, 200, 150, 200. Okay. So here also the duct dimension will come 200, 150, that you can make 200, no problem. Okay. Height only. Remember, I'm sizing this one, 138 liter per second. 138 liter per second, 0.8 Pascal per meter. Okay. Since this duct is having a height of 200, this duct should have minimum height of 250. So 250 already we are having there. Other dimension I need 200. 250, 200. Possible? It's possible. But it is not mandatory because only for this 50 mm changes. From 250, the dimension will be changing into 200. Definitely, but the external dimension is 300, no? So we have to make it 300. We have to make it into 250, 200. Yeah, sure. There is no other option because external is 300 only. So I'll be making a dimension there. Offset it. Ender, I'll be offsetting this into 150 mm. Okay. Now just trim it at TR double ender. Unwanted lines you can trim. What about this one? 138 liter per second. Height is 250. Width is 200. Height is 250. So that will be 200, 250. Okay. This also that is possible there. We'll explain. 200, 250 means if this issue, acoustic insulation allowance, if I was not considering here, then the duct dimension was 250, 250. No? In that scenario, what I can do now, I can extend this until here. Same 250, 250. But here the external is 300 only. So definitely I should decrease that. Okay. So TR double ender. So now acoustic insulation you can extend until here. 200. Okay, 200 means 100 mm. O ender. 100 here, 100 here. Offset this into 150 O ender. 150. Check the angle of taper. 22.5 or not? Yeah, 18. Fine. Now you can trim it. This one, this one, this one, this one. You can delete it. Fine. Now what about this one? 200, 200. 200, 200 O ender. 150, 200 means 100 mm. Enter. 100 mm. 100 mm there. 100 mm here. Okay. Now TR double ender. Here, here, here.
fine. Like I'll be offsetting this one. 100 is fine. Oh, and 100 mm enter. I'll be offsetting this. And this distance I need 45. Shift at approximate distance, angle 45. Here double enter. Okay. This one. Now all these things we can. Okay. Now let me take our lines up here.
We should connect either by the help of a taper to round, or from the face we can cut it. And enter. Okay. Now what about the flexible duct diameter? Flexible duct diameter is 150 only. So O enter. 150 means 75. 75 there, 75 here. This distance I am taking 50 mm. Unwanted lines we can trim now. So for in the place of supply, you want to place this one. Later we can place it. Okay. Now 225 plenum box. Let me select this one. This one. You should make that as a box, then it will be good. Copy. I'll be moving it there. It was already there. Okay. Rotate it. I'll be rotating it like this. Okay. Copy. Now with respect to this point, one I'll be placing there. One more thing I need. Rotate. Copy with respect to this point. One I'll be placing. Anyhow, here rigid connection is not possible. Now flexible duct I should connect. Flexible duct I have already made before now. But this is 200 only. I need 150. So what's the scale factor? 200 divided by 150, no? Not 1.33. We need 150. So 150 divided by 200. Scale factor is 0.75. So copy. Scale this into 0.75 times. Okay. SSC enter. Click the base point. Scale factor 0.75. Enter. So let me take it. No need to check it. It is correct only. Copy with respect to this point. You can place it there. Okay. Okay, later. I have connected there. Here we have to provide a volume control tamper. Or here we can provide RVCD, whatever it may. Single branch, no. Or in the plenum with here also VCD option is available. No, that's fine. Now here also we have to provide the last one. See, here also we have to provide this one. I kept in mind late before. What is the flexible duct diameter here? 150 only, no? So if you want to cut the flexible duct from the face of this duct should have minimum 200, 200. It is already 200, 250. Correct. So definitely from the face we can cut the flexible. 150 dia flexible only. So this should be minimum 200, 200. So this is 200, 250 only. So after this, you don't want to decrease. The same you can extend. Okay. So let me select a line. I'll be making a line there. Fine. Okay. Now the flexible duct diameter is 150. So 75. Here, 75 there. And you can offset this one. More under offset, I'm taking just 2 inches, 50 mm collar. TR double under unnecessary lines you can trim. Now these things you can trim, delete it. Okay, now you can take your flexible duct and you can connect it. So select it, copy. Rotate it. Move here. And this point you can select and you can place it there. If you want to get a more good look, we can try like this. Fine. But one thing here, we should provide a flexible, so this collar length has to be increased slightly. No problem. When you are doing, you can do that. Correct. Because this collar length should be minimum 150, no? 150 there. Correct. If you want to provide an RVCD, volume control damper, the length should be minimum 150 we should provide. Same as the length of. So let me. Diameter of flexible, the same length we should have. Here double ender. But no one will be detailing all these things. But if you are considering, that is good. They will take like 2 inches, then they will consider it. So here I should propose an RVCD, like I'm selecting an ellipse axis end. So solid bilayer, select it. We can mark that later. Here I can give normal VCD. Here I have to propose on this one. Which one? My VAV. Plenum sizing is remaining for this room. Plenum. Because plenum, okay, 225 by 225 diffuser. Here we have selected plenum box 300, 300, 300. Because the flexible duct was 200. Here we don't want, okay, width and breadth you can keep 300, 300. But height we don't want 300 here. Height we can decrease because this flexible duct diameter is 150 mm only. So that's why you can decrease that. So we can edit that. So plenum box. So what I'm doing this, let me make a midpoint. 150 dia flexible duct. 150 dia means this has to be adjusted 75, 75. Oh, offset 75. So 75 there, 75 here. Okay. Now we can trim unnecessary parts. Okay, the middle point we can avoid now. Okay. And plenum box, we can copy that. See this one, 300, 300. Flexible duct diameter is 150, no? So height 200, max 250 is more than 200 is more than sufficient, but I'm just maintaining 250 mm. One number flexible duct, 150 dia. Okay. Labeling we have to do still. Here also we should adjust that. Okay. Just to take it slightly back. So let me make a line from here. Offset this into 75. There, here. Trim the unnecessary portions. Now delete this 2 part. Place it there. Okay. So the same we can keep there as well. Anything else? Thermostat. Thermostat. So just go to the layer HVAC thermostat we have not created. So create a new layer for HVAC thermostat. Okay. And the color number like a 20 or 30 we can provide. Color number 30 I'm providing. 30, I don't like that. 30. You like 20, fine. Okay. So color number 20, HVAC thermostat, create a thermostat. Let me make a small circle like this. Okay. Just select a text already we are having. Copy, move it there. Match property, this one. And that is T. And make it slightly bigger. Let's see, that is 100. So like this also, I'm scaling it into 0.8 times. Now you can move this. Okay, we can save it as a block. Copy. Don't place this on the glass partition. This is glass, so I'll be placing one thermostat. For this room, I am placing somewhere here. And for this one, partition wall only this. So I'll be placing one here. And for this room, I'll be placing somewhere here. If you are placing that near to the door, that will be good. Copy. For training room 1 also, we have to provide it. That one I'll be providing somewhere here. Okay. So I'll be selecting this one. We select it by layer. Okay, no problem. Spline CV I'm selecting. Somewhere from the machine. Keep it. Okay. So again, from the VAV, I guess from here it will come. Okay. Now let me move slightly. This one labeling and all we can do later. So if you want to trim this part, you can trim like this. Okay, so that is my thermostat for this room. The same way. Okay. Labeling and all we can adjust later, no problem. When we are finally, when we are setting the sheet schedule and all, at that time we can adjust it. So, trim. And here I should provide a this one, no, which one? VAV. But for this room, VAV size will vary because flow rate is how much here? 138 liter per second. So VAV dimension may vary there. Because for this space, 138 liter per second is 138 into 2.119, 292 CFM. So definitely the VAV dimension will vary. Let me check it, what dimension it can come. VAV up to 230, the inlet diameter is 100. But above 230, we are having 292. So the inlet diameter will be varying here. It will be increasing into 125. Rest all the dimension is same. All the dimension is same. Only the inlet diameter will be increasing from 100 to 125. So that we have to adjust. Okay. So let me select it. Copy. Move it there. You can rotate it. So inlet diameter. Here we need a how much? What layer it was? SCD. Okay. This one was 95. Okay, keep it there for time being. And let me make a line. This one Actually, the diameter is 125. No, 125 means there is 62.5. 62.5 there, 62.5 here. So this distance we need 125. Okay. And this one is A, 95 only. O enter, 95 enter. Okay. Now we can trim this parts. This one has to be placed here in this path. 200, 250. But I need the central line. Let me make central line of this one. Copy with respect to this center point. I'll be placing it somewhere here. Okay. But outlet diameter is 250, 250. This one is 200, 250. So width has to be adjusted slightly. And here we have to, width is 200 only, no? So from 200, the same like this, we have to change it. So let me place a taper piece. And before that, offset this into how much? What's the inlet diameter? This is 125, 125, right? Okay, offset this. We make a line of here as well. And offset this into 150. Oh, enter. 150 enter. Okay. And check the taper. This is check the taper angle. This angle should be less than 22.5. 14 only. Fine. So here also we can join. And on watered lines we can trim now. Okay. Now after this we need a collar. We need a collar there. Trim this. From this point, the collar distance I need 4 inches. Any distance higher than 4 inches is fine. Offset 100 mm enter. I'll be extending. Now there we can connect the VAV. But even if you are moving the VAV beyond that, that is fine. By clicking the shift key, the unwanted items I'm trimming. So move it with respect to this point, you can place it there. Okay. That is my VAV, and this is 200 duct. But this mouth is how much? This is 250. So from 250 to 200. Anyhow, let me make a line of 150 from this point. And I have to make a taper there. This is a rectangle only. So no problem. What's the taper angle? Angular distance maximum 22.5, just to 9 degree. That is fine. Now you can join this. Okay. So unwanted points we can trim there. That is okay. So this has to be connected. Let's say from there. Ortho has to be turned off. Okay. No issue. Good mark. Okay, so all the VAVs we have connected there. Anything else there? Yeah, one more thing. See here, you can see the machine is located there only, here. And it is delivering to the front area, right? But you can imagine this supplier duct has to cross this wall. Suppose if this duct is extending from the, if this is your finished floor level, and that is your bottom of slab, and if this is your false ceiling level. If this partition wall is extending only until the false ceiling level, then no problem. You don't want to make any hole in this partition wall because it's a common. Even return is also common there. But return should not be common there, because sometimes if the discussion room 2 is functioning, discussion room 1 and the discussion room 3 is not functioning, from which space the machine is delivering the supply, from the same space only the machine has to take the return. So that's why if the return is common, it will be a problem, but there is no other option, right? But anyhow, if you can imagine, if this partition wall is extending until the roof level, this level, we are not having any path for return. This is fine. Discussion room 1, since the machine has located exactly above the discussion room 1, since we are having a return diffuser here, it can take the return. But what about this room? If this partition wall is extending until the slab level, even if the machine is trying to take the return path is not there. So that path we have to arrange. It is not mandatory to take a return duct and connect there. Rather, the path we have to provide. How? Two options. The first option is, when this wall is extending beyond the false ceiling, there you have to provide a wall opening. Wall opening. The dimension of wall opening with the 2.5 meter per second, you can size it. 2.5 meter per second. 2.5 meter per second continuity equation you can apply and you can size it. Otherwise, the same supplier duct you can maintain. But if the return wall opening, when you are sizing, if the return velocity is minimum like 2.5 meter per second, that will be good, or less than 2.5 meter per second, that will be good. It will not create any noise there. Okay. So for example, discussion room 3, I have to arrange a wall opening for return above the false ceiling. Means in this wall, I will be proposing a wall opening. If this is your false ceiling, like this, just an opening. What might be the dimension? See how much flow rate it has to take the return? 138 liter per second, because 138 it is delivering here, the same it has to take. You can apply the continuity equation and you can size it. Correct. Q is equal to area into velocity. Q is flow rate, A is area, V is velocity. Area of wall opening we should find. Area is equal to flow rate divided by velocity. From this equation, we have discussed this in the duct sizing class. From this equation, the Q is in meter cube per second, V is in velocity meter per second. So you know the flow rate, how much it is? 138 liter per second, that is 0.138 meter cube per second, liter per second, divided by 1000. Velocity, I'm assuming 2.5 meter per second. So what area you will get? Area you will be getting 0.138 divided by 2.5. How much it is? 0.0. This much meter square will come. So the wall opening area will be 0.0552 meter square. Suppose if you want to make a square opening, you can take the square root of this one. But if you want to make a wall opening with the height or width is restricted, with that width or height you can divide, then accordingly the other dimension you can find. But we can try for square opening here because we are having 1.2 meter of false ceiling opening there. So take the square root of this one, okay? You'll be getting 234.9 into 234.9, means the dimension will be 234.9 because this is in millimeter, meter only. This value multiplied by 1000, you can convert that into millimeter. 234.9 by 234.9. What it is? 250 opening. 250 wall opening you have to show. Correct. There is one option, 250. Means you can take an opening, like somewhere here you can make like 250 means the width will be 250. Length, it simply has to arrange as per the wall. Move it. Just as per the wall, you can make it like. Now you can simply mark that as WO 250. Okay, wall opening. Or you can arrange a transfer air duct. Transfer air duct means instead of simply providing, but transfer air duct is not mandatory in this scenario. But if you're planning to propose a fire damper there, FD, in the items class we can study FD. Fire damper, wherever the duct is crossing a fire rated wall means in the architecture layout, they will be marking it. They will be highlighting that with the 1 hour fire rated wall, 2 hour fire rated wall. Means if the fire has happened, if the wall material should be able to withstand the fire for 1 hour. That is called the 1 hour fire rated. Accordingly, only they will be constructing the wall. So any duct is crossing the fire rated wall, there you have to propose a fire damper. Fire damper, we are having like a fusible link type of fire damper. We are having motorized fire damper. We are having motorized smoke fire damper. Okay. The function of fire damper is to prevent the fire or smoke. Means motorized smoke fire damper will prevent both the fire and smoke. But normal fire damper or motorized fire damper will prevent the fire. Means it will fusible link type means normally the fire damper, blade, everything will be open only. When the fusible link is melting with respect to the high temperature of fire, in case of fire time, automatically the wall will, damper will close. So accordingly, the air circulation will be prevented. Anyhow, the type and all we can study in detail in the upcoming classes, in the items class. Okay. So wherever a wall is crossing a fire rated, a duct is crossing a fire rated wall, both here, suppose if you are having a wall opening, there also we have to propose fire damper. Any opening, because if fire has happened here from this room to this room, through this opening, the fire should not transfer. But in the fire rated wall will come in data, electrical room wall, generator room wall, okay, data center room wall. Those there only we will be having fire rated wall. These and all it is not fire rated wall. So fire damper is not mandatory there. Only in the fire damper, fire rated wall we have to propose it. But in case if you are planning to propose a fire damper, instead of a wall opening, there you have to provide a duct. There we need a duct, but duct you can simply provide as a piece. Same, what function the wall opening is doing, the same only this will be also doing. This will be acting as the path for return. This duct is called a TAD, means transfer air duct. Function of wall opening and the transfer air duct for this space is similar only. It will allow the return to recirculate back to the machine. Okay, but in this scenario, we are not having any intention to provide a fire damper because it is not a fire rated wall. So a wall opening is more than sufficient there. But in case, suppose if you are planning to propose a fire rated fire damper, then instead of wall opening, there you have to propose a duct. Okay, within that duct, you have to show which one, the damper, fire damper. Okay, so that one you can size with the 2.5 meter per second of velocity, or the same duct, supply duct dimension you can use there, no problem. But if you are sizing with the 2.5 meter per second, it will not create any noise. So that transfer air duct we can size by the help of this one. Liter per second, 138 liter per second. Okay, velocity I'm using 2.5 meter per second. And the duct dimension I need 250, 200. 2.5, 2.5, 250, 250. So even if you are using transfer air duct with the 2.5 meter per second, the dimension you need how much? 250, 250. So that one we should mark 250, 250. So how to show that? You should show that like a bell mouth, but it is not mandatory to show like a bell mouth, but I will show that anyhow. The length of wall is this much only, no? So transfer air duct is 250, like this. 250 only. Okay. So you can copy this one. Somewhere here you can show that, the middle side. Like that, it is fine. If you are proposing like this, that is fine. Okay. But if you are proposing with a bell mouth means if you are going to DW 144, bell mouth details we can find, how we can size the bell mouth. Okay. Ductwork 144 standard. How we can size the bell mouth and all. See, bell mouth, when we are sizing it, this is our transfer air duct. Okay. If you are proposing bell mouth like this, still the velocity will be decreasing because comparing to the duct dimension, area is slightly increasing there. So the velocity will be less. In that scenario, the sound will be too less. That's the advantage of bell mouth when you are proposing there. So bell mouth, from the duct, we are having a dimension A. What's the distance A with respect to the width? The width of duct up to 200, that is 75. Up to 300, that is 100. Our case, it is 250 only width. So we need how much? 100 mm. And the angle maximum is 45 degree. Okay. So let me make that. I'm just selecting this one. And I need the distance 100 mm. Okay. And from this point, I need 45 degree. So shift at approximate distance of 150 angle 45. Okay. Now the reference line you can delete. You can mirror it, MI enter. Okay. Now you can extend it, EX enter, boundary. Okay. Trim it, this one, this one, this one. Okay. Then mirror. This. Now this is your TAD or transfer air duct. You can select this one with respect to the center point I need. See, I'll be making a line here because I need the center point of that. Okay. So just let me select it. Copy. Okay. With respect to the center point, I'll be placing it. Okay. Now this one you can delete. And if you are planning to propose the fire damper within this duct, we can propose it. This that will be acting as a duct for the return path, transfer air duct. Okay. But I'm not having any intentions to provide a fire damper there. So transfer air duct is additional cost will come, metal duct, no. So it is not mandatory. Avoid it. I just need a wall opening there. Okay. But if you are planning to propose a fire damper, even if you are proposing transfer air duct, no problem. It is good only. But even wall opening is fine there. It will arrange the, with the 2.5 meter per second only I have sized it. Correct. The dimension is 250, 250. Fine. So I can mark it, wall opening. Okay. WO, wall opening, 250 into 250 for return. Okay. This is more than fine. So you have to make sure that when you are designing the system, wherever the machine is delivering the supply, from the same space, the return path should be there. Otherwise, the recirculation will be not completed. The machine is not in a position to understand the temperature within the spaces if it is not recirculating the return. Okay, so that's why. Now from this room to here, the return is coming. Now from this room to there, it has to go. Correct. From here, 138 liter per second. Okay. Then from here, it is 138 plus 105, 243. Plus 105, that is 243. Correct. So 243 liter per second, how much we need? 243, I'm converting into divided by 1000. So 0.243 meter cube per second with 2.5 meter per second of velocity divided by 2.5. So this is the area of wall opening. If you are taking the square root of this one, 311 into 311. 300 by 300, keep it there, no problem. 300 by 300 wall opening I need there. Okay, 300, 300. So let me make a 300. Okay. So is it 300 only? No? Okay. I'll just move it to here. So there is wall opening will come above the false ceiling. That is 300, 300. Now the return is also fine, right? Even if you are proposing transfer air duct, that is good. Good. But leave it. Why we are additionally increasing the cost? Now transfer air duct is fine. Okay. Now just let me make the schedule.